proving that two figures are congruent. We have two triangles here, triangle ABC and triangle DEF, and I want to know, is triangle ABC congruent to triangle DEF? So if I'm approaching this like a proof, I should have an idea of how I would go about proving it. So some things we know about congruent figures. Let me jot these down over here. Congruent figures. We know that congruent figures have congruent angles. They have sides with a scale factor of 1. So that means the sides are in a 1-to-1 ratio. And we know that rotations, reflections, and translations all produce congruent figures. So let's start off with what I can find from the coordinate plane. Using my coordinate geometry. So far, all we really know with coordinate geometry is finding lengths, and knowing if things are parallel or perpendicular. So I'm going to use the distance formula. Slash the Pythagorean theorem. So I'm going to do that work over here. I'll catch up with you in a second. So just in case you couldn't read the work before, here it is. We have to repeat that work on the other triangle. So take a second, make sure you understood what went on here, and then we're going to repeat the process. Just to make sure you caught all that, this length here is EF, which I found to be 2.3. This length here is DE, which I found to be 3.6. And then this one, 4, it lay on the grid line so I could just count 4 units. So looking at this list down here, I have shown that the sides are in ratios of 1-to-1 because so 1-to-1, 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 all using the distance formula. So we're going to switch tools and we're going to use some measurement tools. So this time when I measured, I got slightly different measurements. I got 63 instead of 62.5 and 33 instead of 33.5. Does that mean my angles aren't congruent? Probably not. reading the protractor was a little bit inaccurate. If you notice, I had to use the ruler to help me out. So I'm going to call that a human error estimation and say that I have 3 congruent angles. So I've proven that we have 3 congruent angles, 3 sides that are in a 1-to-1 ratio. I'm going to check my work using our last method here. We haven't touched on transformations, which would be using patty paper. So I want to use that a little bit just to show you how that works, and then we'll be really sure that our 2 shapes are congruent. So first off, I'm going to use patty paper to show that the angles are congruent. So Miss Steele, you might be saying to yourself, can't we just copy the figure onto some patty paper and then just move it and see if it lines up? Sure you can, because that would be using transformations. In transformations, we have rotations, reflections, and translations, all 3 of which will always give us congruent figures. The only trick is, if you're going to use this method, you need to make sure you're describing everything as precisely as you can. So I'm going to go ahead and copy my figure onto some patty paper, and then we're going to look at the transformations. If I start off by translating down, and let's go ahead and rotate it into position. So now I have side CA on the bottom, which corresponded to side DF. And I notice that this point here is 3 units from the x-axis, or the y-axis, and this point here is 3 units from the y-axis. So it looks like I could just reflect it. Let me just check. Just sketch in my x-axis, y-axis. I'm going to keep that y-axis lined up, and sure enough, I have a reflection over the y-axis. So we need to jot those down. And I'm going to do that on my patty paper here. Let me give myself a little bit of blank space. If I'm going to use patty paper in transformations, I need to be as precise as I can in explaining myself, so I would be able to write a thorough proof later. If you have questions, don't forget to jot them down and put them on the chalkboard tomorrow when you get to class.